Welcome to The Explainer. Today, we're diving into a puzzle that actually forced logicians to rethink one of their most basic ideas. What does it even mean for something to be true? This is the story of a simple symbol that unlocked a much deeper way of connecting logic to the real world. So here's what we're going to cover. First, we'll look at a puzzle that classic logic just couldn't solve. Then, we'll see the breakthrough idea that changed everything. After that, we'll unveil the specific tool that makes it all work. And finally, we'll explore the incredible new universe of possibilities this opens up for the entire field of logic. Okay, let's jump right in. We're starting with a question that seems simple on the surface, but it's surprisingly deep, and it really stumped logicians for a long time. It gets right to the heart of what we're even talking about when we say a statement is true. All right, have a look at these two sentences. The sky is blue. Grass is green. Now, we all know both of these are true, right? But here's the real question. From a strictly logical point of view, are they the same? Do they mean the same thing? Well, you might be surprised to hear that according to a huge idea in classical logic, Frege's principle, the answer is yes. The principle basically says that these two sentences are just different names for the exact same thing, the concept of true. It's like they're just two different labels pointing to one big box. And this is where things get really weird and you start to see the problem. If both sentences just point to this one abstract idea of true, then the logic completely misses all the unique meaning. You know, the blueness of the sky and the greenness of the grass. Those are totally different situations in the world, but this old system was just blind to that difference. So you have to ask, how did logic get out of this mess? Well, this is where a logician named Roman Suszko comes into the picture. He stood up and challenged that foundational idea, and in doing so, he kicked off what we now call the Non-Fregean revolution. Suszko's big idea was that sentences have to be more than just true or false. He argued that logic desperately needed a way to talk about what sentences are about, the actual real-world situations they describe. Just stamping them with true simply wasn't going to cut it anymore. And this gave birth to the concept of semantic correlates, or an easier way to think of them, situations. This is such a powerful idea because it allows two true sentences, like our sky and grass examples, to point to two completely different, unique states of affairs. Suddenly, logic could finally see the difference between a blue sky and green grass. Okay, so that's a fantastic new idea. But how do you actually write it down in the formal language of logic? It's one thing to have a new philosophy, but you need a new tool in your toolbox to make it work. The solution was beautifully simple. A new symbol. This is the identity connective. It looks pretty straightforward, but it carries a whole new world of meaning. And this table just lays out the difference perfectly. The old symbol, that double arrow, it only compares truth. It just says, hey, A is true if and only if B is also true. But our new symbol, the identity connective, says something way more profound. It says A and B refer to the exact same situation. It's comparing the actual underlying meaning. So this new connective plays by three pretty simple but really powerful rules. First, any statement means the same thing as itself. Okay, that makes sense. Second, if two statements mean the same thing, you can just swap them for each other anywhere you want. And third, and this is a big one, if two sentences mean the same thing, they absolutely have to have the same truth value. But here it is, the absolute core of this whole revolution. That implication only goes one way. Just because two statements are both true, it does not mean they describe the same situation. The link from identical meaning to identical truth is rock solid, but it's a one-way street, and that's what saves all that unique meaning. So now we've got this awesome new tool that can tell the difference between truth and meaning. What can we actually do with it? What new doors does this open up for us? See, before the identity connective, the world of logic was pretty flat. It was a binary world. A statement was either true or it was false. That was it. End of story. But now we can start to talk about ideas that were always really tough to nail down formally. We can get into things that are central to what's called modal logic. Ideas like whether a certain situation is even possible. And we can also capture the flip side, whether a situation is necessary. Is it true in every single possible world? This gives logic so much more texture, so much more power. It lets it describe reality in a way that's far more nuanced. So let's zoom out for a second and look at the real big picture here. Because this wasn't just about creating one new little trick. It was a fundamental shift in how logicians saw their entire field. What Suszko figured out was that his non-Fregean approach gives us a common foundation, kind of like a shared language, to build and study all these other non-classical logics. We're talking about systems that deal with weird stuff like vagueness, paradoxes, or relevance. So it's not just one more idea tossed into the pile. Think of it more like a powerful new lens that lets us understand the entire landscape of logic better. We can finally see how all these different, strange-seeming systems actually relate to one another. It brings a new kind of order to the chaos. And all of this leaves us with one last big thought. We started this journey with a simple puzzle about a couple of true sentences. We ended up with a tool that connects logic to meaning, to situations, to possibility, and to necessity. It really makes you wonder, if we can refine our formal systems this much, what other complex parts of our language, our reality, and even our own understanding are just sitting there, waiting for the right logical tool to unlock them.